Good morning, our listeners, and welcome to our today's class. Today, we intend to look at questions surrounding measures of central tendency and dispersion. Do recall that in our previous class, we pledged that in our next class, we will be looking at questions surrounding these concepts drawn from so many exam bodies cutting across JAMB, JUPEB, screening, university undergraduate examination, and other related examination body. And we intend to solve this problem in a way and manner that we strongly believe is going to boost your courage, your confidence in solving questions surrounding these concepts. We also crave indulgence of those of our audience who perhaps before now had opportunity of having classes on questions pertaining these measures of central tendency and dispersion. To still please grant us your audience as we intend to bring the solutions of these problems in a very simplified approach, which we believe you are still going to gain from the class. The questions have been drawn and written down in this paper I have in my hand. So I'm going to go through them one by one and we solve it together with you. So I'm going to begin from the first question, question number one. Question number one says, and I read, it says, if the mean and the mode of some data sets are 4 and 10 respectively. A data set had earlier been given and the mean and mode computed from that data set, and the value of the mean and mode are given as 4 and 10. So I come to that question number one. Question number one, I am told that the mode and the mean and the mode is given as this. So mean is given as what? 4. And then the mode is given as what? 10. Then the question further says, find the median. The question further says, find the median. So find the median. So I'll first of all write solution. What we can understand from this question is that we can have occasions where someone is given the mean and the mode and asked to find the median, or you are given the median and the mode asked to find the mean, or you are given the median and the mean and asked to find the mode. So one first thing that one has to do is to look out for a formula that connects the mean and the mode, that connects mean, mode, and what? Median. The moment we find this connecting formula of these three parameters, we can easily come up with the answer to this. And do remember that in our last class, we did give the formula that connects these three parameters. So we are quickly going to call it up on the board for you to see before we now begin to solve the problem. And the formula states as, it says that the mean minus mode is given as 3 into mean minus median. So this is the formula that connects these three parameters. Look at the mean, look at the mode, look at the median. These are measures of central tendency. And in the question, I have been given what? Mean to be 4 and mode to be what? To be 10. So what I'll do is, in the place of mean, I'll put in the value of 4. In the place of mode, I'll put in the value of what? 10. And what I have becomes, in place of mean, 4 minus. In place of mode, 10 equals. Here is what? 3. I'll open a bracket. In this place of mean, I'll say write what? 4 minus. In place of median, I'll write median because the value of median isn't given. I'll come over here. 4 minus 10 is what? Minus what? 6. This is equals. I'll open up this bracket. 3 times 4 is what? 12 minus. 3 times median is 3 median. So this is what I have. Then I come over here. Of course, minus 6 and 12 are like terms and should be collected together. So I can easily bring this 12 over here. And on this 12 coming over here, it takes a minus what sign. And what I have becomes minus 6 minus what 12 equals. Here is minus what 3 median. Then minus 6 minus 12 means owing 6 and owing 12, which means owing 18 altogether. And I have minus what? 18 equals minus what? 3 median. Of course, when we have minus at the both sides of the equation, they can easily cancel off. And then this minus will cancel this minus. And I'm left with what? 18 equals what? 3 median. We weren't asked to find the value of 3 median. Instead, we are asked to find the value of median. So we must try to make median to stand all alone. And by doing that, we are going to divide both sides of the equation with the coefficient of what? Of the median. The coefficient is the number that stands before a letter or before what? A number. So that is what we have. A number, a coefficient, a number, it stands before what? A letter, or it stands before a word. This is a word median. The coefficient here is 3. This number standing before the median. So I'm going to divide both sides with that coefficient. We have all over what? 3. All over what? 3. So this 3 will cancel this 3. And I'm left with median alone. 3 here is 1. 3 here is what? Is 6. So therefore, median is equals what? 6. So when we are given a problem like this, the very first thing that we need to do is to look out for the connecting formula between the 3 parameters. And of course, these are connecting formula. And with that, we were able to rattle the question with ease and came up with the answer median equals what? 6. Thank you very much. I really want to believe that you didn't have a challenge with the solution we provided to this question number 1 situation where you do. Please do yourself a favor and equally us a favor by raising your concern in the comment section so that we keep to increase the quality of our classes by attending to questions raised by our audience. Thank you very much. Let me clean so we can quickly go over to question number 2. But before I go over to question number 2, I want to make emphasis to one particular thing. And that one particular thing is this connecting formula between these 3 parameters. So bear this in mind always, all the time, that you need it to be able to solve problems that concerns this kind of you being given the mean or being given the median and asked to find the mode. So bear this particular question for me in mind. Thank you very much. So permit me to clean and we go over to question number 2 together. Question number 2 says, and I read, if the mode of the following data set is 7, the mode of the following data set is what? Is 7. So that question number 2, they say mode equals what? 7. The value of k in the data below is the value of k, the value of k in the data sets below is And the data set, of course, they gave is what? Is 3. They gave what? 3. Data set is what? 3. They gave what? 3, 8, 6, 7, 1, 6, 10, 6 again, 7, 2k plus what? 5, 9, 7, and 13. We have a prior information that the mode of this data set is 7. And we are required to use this information we have and obtain the value of k from this set of what? Of data. So the first thing we do here is we first of all write solution. First of all, write solution. And after that solution, what do? We remind ourselves of what mode is. The number that has the highest occurrence in a set of data is what we call the mode. So we are going to go through the values in the data set and be able to see the number or numbers that occur the most. We come over here, this is 3. 3 occurred once, no other 3 anywhere here. We come over to 8. 8 occurred 1 because there's no other 8 here. We come over to 6. 6 occurred 1, 2, 3. So 6 occurred 3 times. We report it. That 6 occurred 3 times. 6 occurred 3 times. Then we go over again. Here is 7. 7 occurred 1, 2, 3. 7 equally occurred what? 3 times here. So I am going to write 7. 7 equals 3 times. Then we move ahead, come over to 1. 1 occurred only once. We are done with 6. We come over to 10. 10 occurred only once. We are done with 7. 9 is here. 9 occurred only once. And 13 occurred only once. So looking at what we have at hand, 6 occurred 3 times, what we can see. 7 occurred 3 times, we can see. So looking at these two things here, you cannot say that 7 is the mode. You cannot say that 6 is the mode. You can say we have a bimodal something because 6 and 7 occur the same number of times. However, we have been given information clearly stated that the mode is 7. So by implication, this 7 must occur more than 6 in this particular data set. And the only thing that can make 7 to occur more than 6 in this particular data set is for this value which we don't know, which is 2k plus 5, to be 7. That is the only thing that can make 7 to occur more than 6 in this data set. So we are going to assume that this 2k plus 5 is a value 7. Because if it becomes a value 7, 7 must have occurred 4 times, which outcomes the number of times that 6 occurred. So we are going to say, therefore, our 2k plus 5 equals what? 7. In order to make 7 to become the mode of this data set. And then what we have now becomes 5 and 7 are like terms collected together. We have that 2k equals 7. This one going over there makes this positive sign to be negative, minus what? 5. So I have what? That 2k equals 7 minus 5 is what? Is 2. To make k to stand on alone, we divide both sides with the quotient of what? K, which of course is what? Is 2. So we have all over 2, all over 2. These two will cancel these 2 and k equals. 2 here is 1, 2 here is 1. 1 divided by 1 is what? Is 1. So the value of k is what? Is 1. And bringing the value of k and putting into these 2, you find out that this becomes 2 times 1 is 2 plus 5 is what? Is 7. And then that makes 7 to be a value of this, which equally makes 7 to occur the highest number of times in this data set. Thank you very much. As we tend that we did not confuse you. Okay? So when they give a problem like this and you check and you begin to see a particular data set that occur the same number of times, talking about bimodal then what it means that if there is a value of what, a constant, a value of what, of an undefined value or a variable in that data set, that it takes that variable to become 7 for you now to see that the mode in that data set is what, is 7. Thank you very much, as we intend to believe that we profile solution to this problem in a very transparent and simplified form. Do remember to subscribe to our YouTube channels and follow us on our various social media pages for more classes that will be coming after now, so that you become, in fact, the information gives to you firsthand. Okay, let me clean and we go over to question number 12. Permit me to clean. Okay. Question number 3 says, and I read with you. That question number 3 says, what is the mean of first 99 natural numbers? What is the mean of the first 99 natural numbers? This is just the question. Mean of the first 99 natural numbers. So I have question number 3. Question number 3. We should find the mean of the first 99 natural numbers. Natural numbers. We should find the mean of this. So what we are going to do, first of all, we are not going to list all the natural numbers from 1 to 99. No. If we do that, it becomes a little bit cumbersome to be able to come up with the solution quickly. So what we are going to do is to recall the formula that have been proven that one can use to get the mean and the variance of natural numbers. And the mean and the variance of natural numbers are given as this. That the mean of natural numbers, mean, which of course we are going to write as x bar, is given as what? N plus 1 all over what? 2. Where n is the number of the natural number involved in that particular question. So what this means is that this formula is the mean of the first n natural numbers. So the variance is given as this. Variance is given as this. S squared is given as what? N raised to power 2 minus 1 all over what? 12. So the variance of the first n natural numbers is given as n raised to power 2 minus 1 all over 12. So the moment you are given questions like this, rather than going to list all the natural numbers and begin to use your calculating device to sum and divide by that number, use these formulas. And then let me now do a little illustration to help you see what we mean by this. For instance, we are talking about first 3 natural numbers. You find out that the first 3 natural numbers is what? 1, 2, and 3. When you are told to find the mean of these first 3 natural numbers, ordinarily, what we could have done is to come and say that mean x bar is given as 1 plus 2 plus 3 all over what? 3. That is sum of all the numbers divided by the number of the numbers. And this becomes 1 plus 2 is 3, plus 3 is 6. So I have what? 6 all over 3. And 6 all over 3 will be able to give me what? 2. Okay? But then, relying on this formula, n here stands for the number of the natural numbers. And the number of natural numbers here is what? Is 3. So I can easily say that my x bar is given as what? N plus 1 all over what? 2. And this my n becomes what? 3. So this thing becomes 3 plus this one in equation all over what? 2. And then 3 plus 1 is what? 4 all over what? 2. Which of course returns 2. Then what if they say that the mean of the first 4 natural numbers? If they say that, it could have been this way: 1, 2, 3, and 4. And using the formula we know to find the mean, the sum of all the numbers divided by the number of the numbers, it will become 1 that x bar, which is the mean, is 1 plus 2 plus 3 plus 4, all over what? 4. And this means 1 plus 2 is what? Is 3, plus 3 is 6, plus 4 is 10. You have 10 all over what? 4, which of course gives us what? 2.5. But then relying on this formula, we can easily come and say that our mean, which is what? X what? Bar, is given as what? N plus 1 all over what? 2. Where of course our n in this context is what? Is 4, number of what? Natural numbers. And it becomes that this is 4 plus 1 all over what? 2. And is equal, 4 plus 1 is what? 5 all over 2, which is equally what? 2.5. So actually, this formula or these formulas are reliable because they return accurately the values of a mean and the variance from a set of natural numbers. So with that, we now go ahead and solve the question they gave us. They asked us to find the mean of the first 99 natural numbers. So permit me to click our illustration while we, with these formulas now, come up with the answer very fast. So, of course, in this context, our n is 99. So we are just going to see that our x bar is given as n plus 1 all over 2. This is equals. Our n is 99. We have 99 plus 1 in the formula all over what? 2. 99 plus 1 is what? 100. We have that is 100 all over what? 2, which of course is what? Is 50. So the mean of the first 99 natural number is 50. So with this formula, you are at the answer in a fling of the hand. Thank you very much. We still believe that you didn't have a problem as we rallied around providing answer to this problem. The only thing I still want you to keep in mind and hold dear are these two formulas. Hold it dear in your heart. Okay? Let it be what you are picking from us. Be documenting them because they are actually going to form a repository for you where you can easily call something up and then provide solution to problems that is posed to you. Thank you very much. So permit me to clean please while we go over to question number 4. Okay. Question number 4 says, and I read, if the variance of a distribution is 81, the variance of a distribution is 81. So permit me to write that variance as, this is question number 4, permit me to write that variance as s squared equals what? 81. And the coefficient of variation is 30%. Coefficient of variation is what? 30%. Permit me to write that coefficient of variation as C dot V is given as what? 30%. The question says find the mean, x bar. So the question says x bar is equals what? So that is to say that this question reads that the variance of a distribution is 81. If the coefficient of variation of that distribution is 30%, what is the mean of that distribution? So the first thing we try to do is to come up with a formula that connects these three parameters, which is variance, coefficient of variation, and the mean, x bar. Of course, in our previous class, we did provide the formula that connects these three parameters. So we are quickly going to recall it now to use it to solve this problem. Because it's actually the class we had prior that is giving us background to these problems that we are solving. So situation whereby you have not given audience to that class, we encourage you that you call up on that class and be able to see the much that we provided there. It is in YouTube, it is tagged as a class on the measures of central tendency and dispersion. And the second class on it talked about the sources of data, method of data collection, and then sampling. If you go on YouTube and type all these, you'll be able to see these classes. So what we are going to do, the formula we gave in that class is that C dot V is given as 100 multiplied by root of x squared all over what? X bar. That is, that the coefficient of what variation is given as 100 multiplied by square root of s raised to power 2, which is square root of variance all over what? X bar. And of course, this is expressed in percentage. So I can easily say that this is expressed in percentage because the coefficient of variation is expressed in what? In percentage. But they have given me the value of variance, they have given me the value of what? Of the coefficient of variation. What is just left is to find the value of the mean x bar. So I'll quickly do my substitution. In place of coefficient of variation, I'll put 30. So I have my 30% here equals, this is what? 100 multiplied by root. Rather than writing x squared, I'll write what? 81. All over what? X bar, which is of course what I'm looking for. I can quickly say all over 1 here for convenience so that I can cross multiply. This one will go over here and this one will go over here. So 30%, of course, there is 30% here, there is percent here, there is percent here. So the percent can easily go. And I say x bar times 30, I have 30 x bar is given as 1 times 100 is 100 times root 9, 81. This root 81 is just 9, so I can say 100 times what? 9. So this thing becomes 30 x bar is given as 900 because 100 times 9 is 900. So to make x bar to stand alone, I'll divide both sides with the coefficient of what? Of x bar. Okay, so this becomes what? Over 30. This becomes over 30. This 30 and this 30 will go, and I have that x bar is, this 0 and 0 will reduce. Then 3 here is 1, 3 into 9 is what? 3. And I have 1 not left here. So what I have now becomes what? 30. So the value of the x bar, which I am required to find, is what? Is 30. So in this question, the key thing to recall and solve it successfully is the connecting formula. And the connecting formula we have already given is this. So please, do me equally a favor by bearing this formula in mind. Bear this formula in mind, as it is going to help you in doing so many things. You can get yourself maybe a sheet of paper, you can get yourself a small notebook and be documenting some of these strong formula we are using to solve these problems. Thank you very much. You permit me to clean it, and then we go over to our next question, believing that you didn't have a problem with it. If you had, please report it in the comment section. Surely, when we come across it, we'll come to your aid. Thank you very much. To permit me to clean. So we go over to question number 5. Question number 5. We go over there. Question number 5. Question number 5 says, let the average of 3 numbers be 16. Let the average of 3 numbers be 16. If 2 of the numbers are 8 and 10, what is the remaining number? Let average of 3 numbers be 16. If 2 of the 3 numbers are 8 and 10, what is the remaining number? Very simple. So in this case now, we are given that our what? This is question number 4. We are given that our n equals what? 3 numbers. We are equally told that our x bar is given as what? As 16. We are equally told that the 2 of these 3 numbers are 8 and 10. And we are told to find the remaining number. We can say let that remaining number be x. We can say let that remaining number be y. or let it be anything. So if we say let it be x, it means that the three numbers are going to be, if we say let it be x, it means that the three numbers is going to be 8 plus 10 plus what? X. Or let me say 8, 10, what? X. These are the three numbers. And we have been given information earlier that the mean of these three numbers is given as what? As 16. Okay? So do remember that we are going to look for a formula that is going to connect this our n, this x bar, and then the sum of these numbers. And of course, you know that our x bar is given as, these are numbers, we have x, we have what? 8 plus 10 plus x, all over. How many of them are there, which is 3? I have this is to be 3. And we have been given this x bar to be 16, so what I have becomes 16. Okay? Then equals, this plus this is 18, so I have what? 18 plus x, all over what? Over 3. Okay? So I can easily say all over 1 here, so that I can cross multiply. And what I have here becomes what? 18 when 1 goes into it, plus x equals, then I have 3 times what? 16. Okay? So in that case, what I have becomes 18 plus what? X. Of course, you know that this number here and this number here are like terms. So you can easily keep your x here and take this one over here. And this becomes that x is given as what? 3 times 16 minus what? 18. So the moment you press your calculator, 3 times what? 16, subtract it from what? From 18. Subtract 18 from 8, you must have gotten the value of your x. Okay? So this is actually how to go about something like this. Just the moment you do this 3 times this thing, then minus what? 18, whatever thing that is left becomes the answer. Of course, 3 by 6 will give you what? 18. You report what? 8 and go with 1. Then 3 times 1 is what? Is 3. Plus 1 is what? Is 4. Then you'll be able to have 48. So 48 minus 18 now will be able to give you the value of x. Okay? So thank you very much. We still do not believe that you had a challenge while we are going through the provision of the solution to this particular problem. We encourage you, if you do, let us know. So permit me to clean this one while we go over together to the next question. Of course, let us say that that question we are going to go over. Look at the question here and let me read. The question says, and I read, the question says, the arithmetic mean of 20 values is 10. The arithmetic mean of 20 values is 10. So that number 5, that's number 5, arithmetic value of 20 value. So my n equals what? 20. The arithmetic mean of 20 values is 10. So they are saying that the x bar of these 20 values is what? Is 10. They ask a question. They say, then find the sum of the 20 values. Sum of the 20 values. So they ask me to find summation, that my I is running from 1 to 20 of what? Of the xi's. So the moment I can get a formula that connects n, connects x bar, and connect this sum, I'll be able to make sum the subject of formula, and then that becomes the answer. And of course, you know that the formula that connects n, x bar, and this sum is the formula for the what? For the mean. So you just quickly state for yourself the formula of the mean. And that formula of the mean says that my x what bar equals summation I is running from 1 to what to 20 of what xi all over what n. And in our own case here, of course, I can say for convenience all over 1. So that one can multiply this to return that. And I'll be able to have that summation I is running from 1 to 20 of x what I equals. Then this n will multiply this x bar. And I have what? N times what? X bar. And I've been given n to be 20, I've been given x bar to be what? To be 10. So in their places, I will make the substitution. And then this thing becomes, in place of n, I will have what? 20 times. In place of x bar, I'll have what? 10. And this thing becomes 20 times 10 will equally give us what? 200. So the sum of those 20 observations from where they got the mean to be 10 is 200. So when they give you a problem like this, what you need to do is to quickly, of course, some other questions can come here. They can tell you the sum, they can tell you the value of what? Of this mean, and ask you to find the value of n. Then the question can come up like that and ask you to find the value of n. So the moment you do your substitution, you definitely arrive at the answer. For instance, now you sitting down in an exam and you being told that the sum of 20 observation is 200. Then you quickly report for yourself that summation I is running from 1 to what to 20 of x what I is given as 200. That is the information you are given. And you are told that the mean x bar of those 20 observation is what? Is 10. And you are asked to find the what? N, which is the number of observations. In that context, they might not give you this 20 here. They will say summation, it is running from 1 to n. Because this n is yet to be known. So stopping at 20 here is as good as giving you expo that n is 20. So any smart student will just look up there and see 20 there and report quickly that n is what? Is 20. But they will end at this what? N, believing that when you now know the value of n, you can categorically see that that n there is what? Is 280. So what you do there is you still use this formula I gave here. You still use that your x bar now is given as summation of what? Xi. I is running from 1 to what? To n all over what? All over n. And do remember that this x bar is given as what? As 10 equals. This one is given as what? 200 all over what? N. So you can say all over 1 for convenience and cross multiply. N times this is what? 10 what? N is given as 1 times 200 is what? 200. So you can then easily cross multiply, divide both sides with the quotient of n all over 10 all over what? 10. So at this 10 will cancel this 10 and you are left with n. Then this and this is gone and you are left with 20. So on this note, you can categorically say that n is 20. So when they give you this kind of problem, this is how you play around the formula of mean to be able to get the unknown from the formula. Thank you very much. We still believe that we have not caused you any kind of misunderstanding as we are providing answer to that problem. Permit me to clean while we go over to the next number. Okay, that next number says an array. Okay. If the mean of two numbers is 10, if the mean of two numbers is 10, so this is question number 6, mean of two numbers is 10. So my n is equals to what? 2, and then my x bar equals what? 10. If the mean of two numbers is 10, and the mean of three numbers is 20. So let me come here, n again equals what? 3. Then x bar again equals what? 20. They say find the mean of the 5 numbers all together. Someone coming to 2 observation, getting the mean, going to 3 observation, getting the mean. And then in this time around, we are asking you, what if these 2 numbers and 3 numbers are combined together and you are asked to find their mean outrightly? What is the value of the mean? So what you are going to do here is I can call this one my n1, call this one my n2, call this x bar 1, call this one my x bar 2. And I will be able to use that formula Now my x bar 1 equals summation. I is running from 1 to what to 2 because n here is what 2 of what x what I all over what n1 all over n1. In that case, that will make therefore my summation I is running from 1 to what 2 of xi equals n1 times x1 will give me n1 x bar 1. So this is the sum of 2 observations. I will now come and get the sum of 3 observations. If this is the sum of 2 observations, it implies that the sum of 3 observations is going to be sum I is running from 1 to 3 of x what I is given as. This is my what n what 2 x bar what 2. And of course, when I do the sum of these 2 observations plus the sum of these 3 observations divided by what? By 5, I must have arrived at what they are asking me to do. So I am looking forward of going to get sum of I running from 1 to what 2 of xi plus sum I is running from 1 to what to 3 of x what I all over what 5. It's the same thing as this sum of I running from 1 to 2 is given as what? n1 x bar 1 plus. This sum I is running from 1 to 3 of xi is given as what? n what 2 x bar what 2 all over. This 5 I divided here was actually this 3 plus this 2 plus this 3, which is just like n1 plus what? n2. So I have n1 plus what? n what 2. So situation whereby you are given the mean of a set of number and the mean of another set of number, and you are asked to find the mean of all the numbers combined together, easily go with this formula. It will give you the answer quickly. So that what you are going to do now become this equals my n1 is what 2. You have 2 times my x bar 1 is what 10. The sign here is plus. My n2 is what 3 times my x bar 2 is what 20 times 20 all over. My n1 still remains 2, so I have what 2 plus what 3. So the moment, which of course is this time this is what 20 plus this time this is what 60 all over. Here is what 5, which is what 80 all over 5. So with that, you must have arrived at the answer. So when they give you, of course, it can go beyond to giving you for n1 and n2. It can be what? n1, n2, n3, and the rest of them. When it happens that way, what is for this formula is going to be n1 x bar 1 plus n2 x bar 2 plus n3 x bar 3 plus n till wherever place they stopped it, all over n1 plus n2 plus n3 to wherever place they stopped it. And with that formula, the answer easily comes out. Thank you very, very much. We still strongly believe that we didn't cause a problem in that particular question. Thank you very much. So permit me equally to clean here while we try to solve another problem that they raised here. They say, find a standard deviation of the first 50 natural numbers. The standard deviation of the first 50 natural numbers. So in this my case now, which is I think question number 6, I guess, my n is equals to 50. But we are talking about natural numbers. And they ask us to find the standard deviation. And of course, you know that standard deviation is the square root of what? Variance. So my standard deviation, let me write it with s, is given as square root of what? S what? Squared, which is talking about variance. We now say but s squared is given as what? N raised to power 2 minus 1 all over what? 12, which is the formula of variance for first n natural numbers. So what I'm going to do is to carry this formula and put in the place of what? This variance. And my s now become square root of. In place of this n, I will write what? 50. So I have 50 what? Squared minus. Here is what? 1 all over what? 12. So the moment you say 50 times 50, which is what we mean by 50 squared, then minus what? 1 divided by 12, get the square root of that, you must have got the value of the standard deviation. So that is exactly how to go about this kind of problem. We equally want to believe that we have not caused any kind of problem for you. We have not caused any kind of a problem for you. Thank you very much. Let us equally try to look at another number. Let's equally try to look at another number. Okay? So permit me to clear. Okay. That number we tend to look at says, and I read, the arithmetic mean of x1 and x2 is 5. If x1 equals 3, then x2 is. It's too simple. It's very simple. Let us call it number 1. The arithmetic mean of x bar 1 and x bar 2 is 5. So x bar 1, comma x bar what? 2. The arithmetic mean of x1 and x was 2, they say is given as what? 5. So it means that x1 plus x2 all over 2 is given as what? 5. But we are told that x bar 1 is 3, so in place of that x1 is 3, so in place of x1 I'm going to write 3 plus x what? 2 all over 2 equals what? 5. I can say all over 1. So I want to multiply everything. 3 plus x what? 2 is given as 2 times 5 is what? 10. So x what? 2 equals this 3 going over there, 10 minus 3. And x2 what equals 10 minus 3 is what? Is 7. So I'll be able to have that place to be what? To be 7. So that is the answer for this very one. It is not really difficult. It is very, very easy. Okay? So let us now quickly go over to another number and be able to trash it quickly. We are calling that one number 8. That number 8 says, and I read, the mean and the variance of 10 observations are given to be 4 and 2, respectively. The mean of 10 observations, let me call it number 8. The mean of 10 observations, so my n equals what? 10. Its mean x bar is given as what? 4, and its variance, which is s squared, is given as what? 2. So they now ask, if every observation is multiplied by 2, if every observation in these 10 observations is multiplied by what? By 2, the mean and the variance of the new series will be. So when you come inside this 10n observation and you multiply each of the observation by what? By 2, what is going to be the mean and then the variance of the new series? Okay? So of course you are going to have, they gave a formula with which to do it. And that formula they gave to do it is that when a particular constant is used to multiply each of the observations, that its mean has been given, the mean of this new series is going to be that particular constant with which they multiply each of the observation, use it to multiply the what? The mean, and you equally arrive at the answer. So, which means if I want to find the mean of the new series, they use the 2 to multiply the what? The each of the observation. I will now use that 2 to multiply the what? The mean, x bar. So the formula for the mean of the new series is 2 times x bar. This 2 is that constant with which they multiply each of these ones. So it now becomes what? Which it becomes what? 2 times what? 4, which becomes what? 8. And then for us to be able to get now what we call the variance of the new series, we are going to square this particular number with which they multiply all the observations before we use it to multiply the variance of the old series. So it is now going to be 2 raised to power 2 multiplied by what? By s squared. And my s squared here is giving us 2. So what it implies that this thing becomes that 2 raised to power 2 multiplied by what? 2, which is 4 times what? 2, which is equals to what? 8. So we can suggest that you make some maybe cross-checking of this statement we gave here by picking up a set of data, getting the what the mean and getting the what the variance, and using a particular constant to multiply all the numbers you have got in your data set, and then recomputing the mean and the variance to be able to know whether it is in line with what we have just given here. So I equally want to believe that you did not have a challenge in this particular problem which we solved here. So situation whereby you still have a problem, you can easily raise your concern. Okay? Now, permit me to quickly clean it. So the next thing we are going to do here is what they gave. They gave us a table. Let me call it question number 8. I can't remember exactly the number of questions that this is supposed to be, but let me call it question number 8. They called here what? X, they called here F. So they gave us something like this. So here is 2, here is 4, here is 6, and here is 8. And they gave us here 4, they gave us here W, they gave us here 6, and they gave us here 5. And the question here is saying we should find the value of W. To find the value of W. Of course, for us to find the value of this W here, it is better that we use the idea of mean to be able to find, because we are looking for something, a formula that is going to connect all the value of X and connect the value of frequency. And that formula is what is the mean. Because they told us, of course, that the mean of this thing is 5. That's another additional information. That the mean of this thing is given as what? As 5. So we should use this idea that the mean is 5 now to be able to solve that problem. And of course, we are going to say that our x bar is given as what? Summation I is running from 1 to n of x what I. But because there is a frequency here, you are going to add summation of f I x I all over what? Summation of f I. That becomes the formula of mean because of the place of what? Of the frequencies. So we have been given that this x bar is 5. So I'll just write what? 5 equals. Then I'll come here. What this means, Fixi means taking each of the value of x and multiply the what? The frequency. So this thing becomes what? 2 times 4 plus. Here becomes what? 4 times what? W. That is for here. Plus. Here becomes 6 times what? 6 plus. Here becomes what? 8 times what? 5. All over. You sum all these things, which is a 4 plus W plus 6 plus 5. So this thing becomes 5 all over 1 for convenience. 2 times 4 is what? 8 plus. 4 times W is 4 what? W plus. 6 times 6 is what? 36 plus. 8 times 5 is what? 40 all over. 4 plus this is 10 plus this is 15. So I have 15 plus what? W. So what you just need to do is to say 8 plus this 40, 48 plus this 36, so that you'll be able to have sum all the numbers, keep the one with the letter differently. Then cross multiply by using this 5 to multiply this. In fact, the simplest thing is at this point in time, your effort should be how do I make W a subject of formula to stand all alone in all these things. And of course, it's very easy to do that. Just sum the numbers and then keep the letters differently. Come at the level of cross multiplication, cross multiply. Collect your like terms. On the course of collecting like terms, you isolate what? Your W at one particular side of what? Equation, preferably at the left-hand side of the equation. So thank you very much for your audience. Then we are quickly going to say something which most of the time they do. They say that when a set of number is given. And then the variance must have been computed from that set of number. That when you increase those numbers by a particular constant, that it does not affect that variance, that the variance still remains the same thing. So somebody can say, if the variance of minus 1, 1, 0, either 1 and 2 is so and so number. If this number is increased by 2, what becomes what the nature of the variance? The moment we look at that particular one, we maybe come to the end of this class in order to manage the size of the video. So permit me to clean this one while we do that one quickly. So let us look at numbers like this, that the numbers they give is like this. I have something like minus 1, I have something like what? 0, I have 1, I have 2, and I have, let me say, I have 2. This is number I have. So let me now compute what? The variance from this number I have. And of course, we know that to compute what the variance, I am going to use the formula I gave, which we call the computational formula. Computational what formula? And that computational formula is given as that my variance s what squared is given as, we have summation of what? X what I all squared minus, or let me just say summation of x squared minus summation of x all squared all over what? N, all over what? N minus what? 1. Of course, people should be careful because at times you see this, at times you see s squared is given as summation of x squared minus summation of x all squared all over n all over what? N. The difference between this and this is n minus 1, this is what is n. Most of the time in some examination bodies now, when they give this kind of a problem, they might be expecting you to use this particular formula, the one that with what? N. But while at times we make emphasis here and give you a condition, that you can use this one when n is less than what? 30. But you can use this one when n is greater than or equal to what? 30. It's because this formula now, they always refer it to what? To as a population formula. That is the population formula for variance. And this one, the formula for sample variance. So, and we are saying in statistics that when n is greater than or equal to 30, we might be referring to that observation as being large. Okay? So this and this should not confuse you. And most of the time, the answers between the two are very close because the question of just subtracting n from this denominator here. So situation whereby you sit for a particular exam and then after you must have used this to compute because they didn't give you any information about, you should use what we call unbiased variance. This is what we call unbiased variance of the population variance. This one, of course, is what is biased when we are using this formula now to compute from the sample. And we say that an estimate, these and these are estimators. We say that an estimator is what? Is unbiased. If and only if the expected value of that estimator gives you the population parameter. And it's only this one that is expected value can give the population parameter, which in this case is now is a sigma squared. But this one doesn't give this one. This one has a biased quantity. Okay? So do not bother if you go for an exam and then you use this thing to solve, you look at the options, you couldn't find it and the rest of them, you just divide your answer again with what? With your n, and be able to look at the option to be able to pin down exactly the formula they want you in mind to use to solve. I'm saying this because of those who will be writing either JAM or WAEC and the rest of them. Most of the time in the university, especially in Department of Statistics across the globe, this is always used for small sample, while this is used for large sample under these conditions. So let me quickly clean this. One of these, which I want to use the first one. So using here now, what I'm going to do is I'm going to square each of these observations. So I'll now come here and have what we call this, let me call this one my x, call this one my x what squared. Under this my x, I have minus 1, I have 0, I have 1, I have 2, and I have 2. Here I have minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 2 squared is what is 4. So I will now sum this. So summing this means minus 1 plus 0 minus 1 plus 1, it has gone. So I have 2 plus 2, which is what? 4. Here I have 1 plus 0, 1 plus 1, 2 plus 4, 6 plus 4 is what? 10. I have this to be 10. So I'll now quickly come over here now. So what I'm going to have here now becomes that my s squared now, is given as summation of x squared has given me what? 4. So I have, or has given me what? 10. So I have what? 10 minus. Summation of x here is what I have to be 4 here. So I'll put what? 4 all raised to power 2 all over. N here is what? 1, 2, 3, 4, 5. So n is 5 all over. N here is what? 5. 5 minus 1 is what? 4. So this will be able to give me 10, which is here minus. This is what? 16 all over what? 5. Then all over what? 4. This is what I have for this particular one. Okay. Now, let me now say that the number are increased by a particular value. And that particular value is what? Is 1. And I'm going to increase all of them. Because actually the variance is the measure of the distance apart between each of these observations. And if you increase all the numbers with a particular value, the difference between each and every one of them, in fact, will still remain the same thing. And that's why they are saying that the variance doesn't change. So assuming now I increase it what? By 1. So if you increase it now by 1, or let me increase it what? By 2. If you increase it by 2 now, minus 1 plus 2 will give me what? 1. This one becomes what? 2. This one becomes what? 3. This one becomes 5. And this one becomes what? 5. And in that case, you are now going to come here, and then you have your what? Your x what? 1, and then your x1 what? Squared. X1 here is referring to this new one, which is 1, which is 2, which is 3, which is 5, and which is 5. Okay? So I increase it by 2, sorry. So, and then, which means here is 4, because I increased by 2. So minus 2 plus 2, this 2, 2. So here is 4 and 4. So here is 4, and here is what? 4. So here becomes what? 1. Here becomes 4. Here becomes 9. Here becomes 16, and here becomes 16. Then we'll be able to sum. So you say this plus this is 3. This is what? 6. This is what? 10. This is what? 14. So this to this is 32. Plus this is what? 36 plus 9. So you have 36 plus what? 9. So this will be able to give you this to this is 5. You have 5 here. Then to this is what? You have 45 here. So what you now have here becomes what? 40 what? 5. Then you now come to this formula. Summation here becomes what? 14. Summation of 45. So in place of a summation of x squared, you have what? 45 minus. In place of summation of x, you have what? 14. You have 14. Then all raised to power what? 2. All over what? 5. Then all over what? 4. Because 5 minus this is this. I promise you, try check this and this. The answers are the same thing. So actually, when you increase the number by the same value, it doesn't affect what it means. Thank you very much. Let us try and manage the size of the class. We made you a promise of going to come up with so many questions to solve together with you. We strongly believe that we must have impacted positively on your understanding of questions in measures of central tendency and dispersion. We still look forward of your audience in our next class that will be coming. Most likely, it is going to be measures of central tendency and dispersion in grouped frequency table. Because the one we did earlier is for ungrouped frequency table and for an array of data. And if you watch, all these questions which we raised here and solved, none of them concerned for the grouped frequency table. So most likely, we should be having another class that will be dwelling on measures of central tendency and dispersion, and possibly measures of partition in grouped frequency table. Thank you. Do remember to subscribe for us on our YouTube channel. Follow us on our different social media pages as we make committed efforts to simplify mathematics and statistics, which ordinarily terrifies students in a way and manner that students begin to develop love for these subject matters. Thank you very much.